right click on MCS, go for edit, keep that MCS at this particular point, say OK. Next is specifying workpiece, specify this particular part. Next you have to consider this raw material by specifying the blank. I will go for bonding block. I will keep this as my input. So workpiece selection is over. Next I have to create operation. One method is right click here, go for insert operation, mill contour. You will get this adaptive milling as second option here. Otherwise click on workpiece and go for create operation. The same pop-up window you are going to get. So select this adaptive milling operation. You may observe when you keep a cursor on this one, it is recommended for efficiently removing large worm. You may observe efficiently, the word, underline that one. So it is used to rough by removing material in planar cut levels normal to a fixed axis. In side cutting edges, it will come in a contact. For this particular operation to be generated, you have to specify part and blank. It is compulsory. And also if you are using any local operation, that time you have to use trim boundary, which we have seen in last session 9. Trim boundary we have used and generated, that you can consider. Already we have specified part and blank. If you are doing roughing, then you may consider mill rough here. Otherwise you keep method as it is, then enter into the operation. The first and foremost thing is to create a tool. Here I am creating a tool. When I try to create a tool, at that moment you may observe the tool subtype, only one type of cutter is supported for this. If you take ball mill, it will not support, it will support only bullnose cutter or end mill. Here I am taking end mill. Let's take 25 diameter and nose radius 2. We'll make it as 25 and nose radius as 2. And also I want to consider some holder to this one. I will take it from library. I am expanding library. Here there is option retrieve from library. I don't know exact library reference, so I am clicking this mill drilling operation. I don't know the library reference, so I will click OK. What all the role holders which are available in the directory, it will be shown. You can select your own, then say OK. So next is range definition. Here it is kept automatic. If you want, you can specify. The most important thing is cut levels mode in range definition. Cut level, it has taken 95% of flute. You may when you see the cutter, here we have given flute length as 50 and the total length is 75. When you see this particular operation, it is considering 95% of flute. It means it will do whole milling like structure and it will create one small region. From there it will start removing material by sideways. So the depth it is taking is 95%, means whatever the value it is taking 90%. If I take 50%, means up to 25 it will go. From there it will start machining by sideways. Either you can give by percentage of the flute length or instead, if you want, you can use percentage tool diameter. Maximum people are using percentage flute. The next is width. Width means after one pass, if you are going for the next pass, how much width you have to keep in between, that also you can mention. In image you may observe, if there is a width 10% is available, then only it is generating. If it is less than that, this cutter will not go. Next is step over. Step over is nothing but after one pass, for next pass how much shift if you want to do. Here we have given 6.4% of cutter and minimum cut radius. Whenever there is a uh, sharp corner, at that moment if your cutter tries to go to the diameter and the slot diameter, if it is same, then there might be chances of your cutter will stuck over there. So to reduce that one, you have to give minimum curvature radius. First I will generate this one, then you may observe how exactly it is creating. You can see it has created one pass only and it has left some region below. So if you want multiple depth per cut here, I can mention 30% of tool. At that moment you may observe there are two passes it has created. If you want 20% of flute, it will create 3 passes. It is up to you how much pass you want to remove. If you want only within one shot, if you want to remove, or multiple number of times if you want to go, you need to select this step per cut according to you. I can verify this. Take 3D dynamic for better visualization. Play this one. Now you may observe it is going like a whole milling. Then when it reaches that whatever the percentage which we have mentioned, like 20% I have mentioned, after that it will start removing metal by side cutting edges. When you look carefully, so all side cutting edges are means the 20% of cutting sides are coming in contact with the part. So also the pass which is created is very smooth. For next range it is going, it will make like a hole like structure, hole milling like structure. Then it will start machining by sideways once it reaches the range. So it is very smooth, and you may observe chips are also uniform which are coming out. Here I have not mentioned any stock. For roughing we need to specify some stock. I will increase the animation speed so that it will go in speed in a secondary region. So one thing, if you want, you can keep like this and you go for rest roughing for this to remove this other region. Otherwise, in this particular operation itself, there is an option which we call it as bottom up cutting. Once it reaches to the range, then again it will start machining backwards, means to remove this particular region which is forming a step like structure, right? That we have to give this bottom up cutting. If you want, you can give it. Now I will give this part stop so that as it is roughing. So I will turn on this bottom up cutting. You can keep this between level or after last pass. So it is up to you. After last pass I will give. And step up distance after machining to the region, here I will make 30%. When it reaches 30%, then it will start cutting in upward direction. Like step up distance I can mention 10%. Here it I have given. I will give in terms of mm, 3 mm. Okay, minimum depth you can mention as 2 mm. Minimum depth is nothing but the last pass, 2 mm. Up to 2 mm I want. So bottom up cutting, if you are willing to add, then only you have to add. Otherwise, if you want to skip, then keep off. Generate. So using bottom up cutting is best practice, so that your roughing time will get reduced 60%. If you won't take this bottom up cutting, then your roughing time will get means compared to cavity mill, 40% less time it will take. If you use this bottom up cutting compared to the cavity mill, you are getting minimum 50% is reduced time. So now I have given 30%. When it reaches to the 30% of flute length, means 15 mm it is going, and then after reaching all the region, then while coming back it will remove every time 3 mm. First it will go to the bottom region, up to the bottom region. Previously whatever we have seen, similar to that it will go. So once it reaches that particular region, it will start removing material by while coming backward direction. You may see 3 mm, 3 mm, every 3 mm it will go, it will try to remove. With respect to the last operation, it is removing more material. If you keep bottom up cutting, it is a very advantage. Like this, you have to do adaptive milling operation if your cutter is carbide cutter and it is having side cutting edges. You don't go for HSS cutter and inserted cutter for this particular operation. In geometry, the same other things are similar. Go to feed and speed, specify your own speed and it will remove. And in strategy, if you want depth first you can keep, otherwise if you want level first you keep, but in adaptive milling keep depth first itself. If you want a pillar cutting means if you want helical motion, keep helical motion, cut with helical motion. If you want adaptive pattern, keep adaptive pattern. Adaptive pattern is the best one. If some regions are very small, which are lesser than or equal to 70% of tool, if you don't want to remove, then you can specify here. In non-cutting modes, no need to specify anything. Now here it is making helical, which is bigger in size. If you want to reduce that one, you can reduce it to make 30. So while engaging, it will make 30% of helix and it will enter into the region and it will try to remove. In transverse, you can keep a part safe clearance as 3 mm. So it will always try to avoid collision with the other region, which is non-cutting region. You may observe in this particular image carefully. So whenever I am machining beside this particular pillar, left side and right side, so when it machines to the left side, whenever it is going to the right region, at that moment, whatever the peak height of that particular component in between, from that how much safe distance you want to keep, that you need to specify here. If you want any part specific clearance safe, if you want to mention, you can mention it, otherwise say okay. So like this you have to do adaptive milling, which will be helpful you to reduce machining time by 60% and tool life will get increased by 4 times. Nowadays all people are using this strategy for roughing